Hi, welcome. I'm Philos, and I will take you through how to perform one sample t-test for mean using SPSS and how to interpret it as well. So without wasting much time, let's start. Now to start with, let's take for instance, the Vice Chancellor of University of Ghana claims that the average height of students in a particular college is 1.54. That's 1.54 meters tall. Okay. Now let's say you collect data on height of students in that college also, and then this is it at the fourth column here, height. Okay, so you have 1.73, 1.55 going. Now you are going to perform one sample t-test to check if your sample mean is statistically significantly different from the mean stated in the claim. Okay, so that's what we are interested in one sample t-test. But for you to perform one sample t-test, the following assumptions must hold. Okay. Now when you look at my sample size, you realize that the sample size is less than 30. Okay. And then the population standard deviation too is not known. So I'm using T. Okay. And then another assumption that must hold is that it should be approximately normally distributed. Your data should be approximately normally distributed. And also, your data must be scale. What I mean by scale is that it should be on interval or ratio level of measurement. Okay, it shouldn't be nominal or ordinal. Okay, it should be on interval or ratio level of measurement. If you remember, height is on ratio level of measurement. Okay, so your data should be on either interval or ratio level of measurement. Okay, before you can perform t-test also. Another assumption is that the data should be independent of one another. Okay, and also there should be no extremely large or low value, which is called outlier. Okay, now as I said earlier, that let's say the Vice Chancellor claims that the average height of students in a particular college is 1.54, and then we are going to perform one sample t-test, okay, to check if our sample mean is statistically significantly different, okay, from the mean stated in the claim. Okay, that's what we are interested in. So the first thing we are going to do is to state the null and alternate hypothesis. Okay, now the null hypothesis, which is H0, says that there is no statistical significance difference. Okay, but the H1, which is the alternate hypothesis, says that there is a statistical significance difference. Okay, so you can write them down. Write the null and alternate hypothesis down. Okay, for now. Now, to perform one sample t-test, first you go to the menu here and then check out for analyze. Okay, so you click on analyze. Then you move to compare means. Don't click on it. Okay, then move to one sample t-test. Then you click on it. Then this dialog box will display. Okay, now we want to test the mean for height, isn't it? So you select height. Now when you select height, then you click on this arrow to the right. So when you click on it, it will bring you to this box here. Okay, then you come to where they've written test value. Now at the test value, you are going to type in the mean given in the claim. Okay, the mean in the claim, the mean stated in your null and alternate hypothesis, which is 1.54. Okay, since the Vice Chancellor claims that it is 1.54, that's the test value. Okay, then you come to option here and then check out the confidence interval percentage. Now the default one is 95%. Okay, and I'm also going to use 95%. You can edit it or change it to 99% depending on your research. Okay, but there's something I want you to know, that 95% confidence also means 5% level of significance. Okay, that is 100 minus 95, that gives you 5. Okay, and 99% level of confidence is the same as 1% level of significance. So I want to use the 95% level of confidence, which is the same as 5% level of significance. Okay, so I just click on continue. Now my test value is there. Alright, 1.54, and then I have the height here, and that's what I want to test. So you click OK. Then instantly SPSS will display these two tables. Okay, now the first one here is a descriptive statistic, and then the second one is the one sample test. Okay, t-test. Now when you look at the first table, you see that n is 12. It means that the sample size is 12. meaning there were 12 respondents. Okay, and then when you look at this place, they've written mean. So the mean is 1.5808. Now this mean is the sample mean, is the mean of the sample collected. Okay, as in those students who gave you their height, their mean, that's the sample mean, 1.5808. It's also known as point estimate. Okay, and then the standard deviation is 0.13641. It's the same as saying 0.13641. And then the standard error of the mean is 0.03938. Standard error is standard deviation divided by square root of n. You take your calculator and put on it 0.13641 divided by square root of 12. You see that you will definitely get 0.03938. So let's come to the t-test. Now the t-test will help you arrive at a decision whether to reject the null hypothesis or not to reject it. Okay, now you see that the test value has been written at the top here, which is 1.54, and then this t here, which is 1.037, is called the test statistic or the computed t. Okay, and this is the degree of freedom 11 from 12 minus 1, that is n minus 1, and this is the p-value. Okay, this is the p-value. Okay, and this is the mean difference, and this is the confidence interval. Okay, now to make decision, I'm going to show you 3 different ways of arriving at your decision. Okay, and you still end up getting same answer. Okay, now the first one is using the critical value method. Now how is the critical value method used? So kindly write this down. If the absolute value of the test statistic is greater than the critical value of t, we reject the null hypothesis. Okay, but if the test statistic, they are in absolute value, okay, absolute means that if the thing is even a negative answer, make it positive. Okay, now if the absolute value of the test statistic is less than the critical value of t, okay, you do not reject the null hypothesis. So let's check that and see if we should reject the null hypothesis or not to reject it. So let's take the t table and then check the critical value of t. Now, what is the level of confidence? 95%, right? And the significance is 5%. So to check it on the table, we go to the t table. Now, at the t table, you come to where they've written two-tailed test, okay? And then you check out for 5% on that line. So this is 5% here. And then you check where they've written degrees of freedom. Now, your degree of freedom in this particular one is 11 because the sample size is 12. When you subtract 1 from 12, you get 11. So this is the degree of freedom. So you trace this 5% downward to 11. So it will fall on 2.201. 2.201. So this 2.201 is the critical value of t. Okay, is the critical value of t. So let's go back to SPSS and then compare it with the test statistic. This is a test statistic 1.037. As you can see, the test statistic is less than the critical value of t, which is 2.201. So since the test statistic is less than the critical value, then we do not reject the null hypothesis. And what does that mean? Now, the null hypothesis says that there is no statistical significance difference, isn't it? So, since we are not rejecting the null hypothesis, it means we are saying that there is no statistical significance difference between the sample mean and then the population mean. Okay, the population mean is the 1.54, the test value. Okay, even though we can all see that 1.54 is different from 1.58, but that's not what we are interested in statistic. We are interested in checking if there is statistical significance difference. That's what we are interested in. So there is no statistical significance difference between the test value and then the sample mean. Now the second method is using the p-value method. Now to use the p-value method, this is the rule. Okay, please write the rule also down. Now the rule is that if the p-value is less than or equal to alpha, alpha is the level of significance. Okay, so if the p-value is less than or equal to the level of significance, then you reject the null hypothesis. But if the p-value is greater than the level of significance, you do not reject the null hypothesis. So now let's check. Here, our level of significance is 5%. If you convert it to decimal, that will be 0.05. Please, you have to put it in decimals. Then let's compare it with the p-value. This is the p-value. The one they've written sig two-tailed on it is the p-value. So let's compare the p-value with the level of significance. Now, if you look at the p-value is 0.322. As we can see, 0.322 is greater than 0.05. Since this p-value of 0.322 is greater than the level of significance of 0.05, then we do not reject the null hypothesis. So, as we are not rejecting the null hypothesis, it means that we are saying there is no statistical significance difference. Okay, so you see that we end up making same decision we made using the first method. Then let's also look at the third method. The third method is by using a confidence intervals. Now, to use the confidence intervals method, okay, now you look at the sign of the lower and the upper. Okay, if they have the same sign, then you reject the null hypothesis. But if they don't have the same sign, then you do not reject the null hypothesis. When I say the same sign, it means if they are both positive, okay, you reject the null hypothesis. If they are both negative also, you reject the null hypothesis. But if one of them is positive and the other is negative, you do not reject the null hypothesis. So when you look at this particular one, you see that one of them is negative, the lower is negative and the upper is positive. So they do not have the same sign. So for that matter, we do not reject the null hypothesis. So since we are not rejecting the null hypothesis, it means that we are saying there is no statistical significance difference between the test value of 1.54 and then the sample mean of 1.5808. So we've ended up making our decision. So in case you want to copy this table, you can click on the table and then press Ctrl+C. Then you go to wherever you want to copy it to. So let's say I'm taking it to Word. So I'll open my Word and then I click Ctrl+V. Then instantly I'll have it in Word document. Okay, so you can edit it anyhow you feel like. And then you can also paste it in Excel. So let's go to Excel and see. Now in Excel, you can just also press Ctrl+V after copying it from there. So you see that you have it in Excel also, and then save them. Okay, so let's go back to the SPSS. So since you've copied it to Word document, anything you want to use it for, you can use it there. But you can also save it in SPSS file form. Okay, so you can just go to File and then go to Save. You can just use this Save, okay, the blue one. So I click on it, then this pops up. Okay, so you can give it any file name. So I want it to be the height file. Okay, so height file. So you can choose to save it here in document, or you can choose another location to save it. So I want to save mine at Philos. So I select where I want to save it. So this is where I want to save mine at Philos, and then I click on save. So when you're done saving, you can decide to close this part, or you come to the taskbar and then go back to the data view. Do well to subscribe to the channel so that you can easily see the next videos whenever we post them. Thank you.